Good morning, Tahmina Khan is here. This is video number 2 on momentum. In the first video, I have explained the basic definition and few basic examples to build the concept. If you have not seen it and if you want to see it, you can go in the description and press the link. So momentum, as I told you, is a topic which has been introduced in A-level mathematics M1 this year only. So in the past paper, you may not find word problems on it. So before I begin, you can see on the top my blog address. TKMaths is fun. There is no gap, okay, without gap. TKMathsisfun.blogspot.com. So you can go on this blog and see the videos which I have made earlier. In this video, I have explained two questions which are of little advanced level compared to the one we have discussed in the video 1. So in this question, it is talking about two particles P and Q which are moving in opposite direction on a same smooth horizontal, on the same straight line on a smooth horizontal surface when they collide. So if they're moving in the opposite direction and they collide, it means they are moving toward each other, because moving away from each other also opposite direction, but then they cannot collide. So P has mass 0.4 kg and speed 3 meter per second. Q has mass 0.6 kg and speed 1.5 meter per second. And immediately after the collision, the speed of P reduces to 0.1. So what you have to find the speed of Q after the collision, and what is given to you, P and Q are moving in the same direction after the collision. So the question is telling you that after the collision, they are moving in the same direction and you have to find the speed of Q. So let's see the question in the diagram form. It's easy to understand then. So P and Q are moving in the opposite direction. Okay. And I have explained to you why I have taken this direction, because they will collide. This is the mass and velocity of P, and this is the mass and velocity of Q. And it is negative because Q is moving in the left hand side. After the collision, the body A has velocity 0.1. So this is the information given to you in the question. And we have to find the velocity of Q. Okay. So now, using the law of conservation of momentum, and momentum is mass into velocity. So law of conservation of momentum says that before the collision and after the collision, the momentum of a system remain same. So let's see here. So this side is representing before the collision, mass into velocity of P, mass into velocity of Q. So you can see here, I'm just substituting the mass of P, velocity of P, mass of Q, which is 0.6, and velocity of Q minus 1.5, because it was moving in the left hand side direction. Opposite direction we have to take opposite sign. And this is equals to mass into momentum of body P and Q after the collision. So P mass is 0.4, but speed is reduced. It was given in the question, the velocity of P reduced to 0.1. And velocity of Q we have to find out. So we are writing it V, and mass is 0.6. So this helps to form an equation. So I'm simply picking up calculator, finding out values and calculating it. I hope you have no problem in it. You can easily calculate this velocity, right? So now they are moving in the right hand side direction. I'm getting plus. Let's see what this question 2 is about. Part 2 of the same question. Okay, so the part 1 was saying that after the collision, the P and Q are moving in the same direction, right? Now part 2 is saying that P and Q are moving in opposite direction after the collision, right? So find the distance between the object after 3 seconds of collision. So let's see what we will do now. So now part 2, I'm explaining in the form of diagram. After collision, P and Q are moving in the opposite direction. So this is the meaning of the question, right? P is going in this direction, Q is going in this direction, and then it is asked that after 3 seconds, what will be the distance between them? Okay, so let's see. According to the law of conservation of momentum, before collision, the momentum of the bodies is equals to after collision. So momentum is mass into velocity, mass into velocity. So this is the scene before collision. Now after the collision, P is 0.4 into minus 0.1. Reason is it is going in the opposite direction, left hand side. And this one is going in this direction now, right hand side. So that's why I have written 0.6 into V. So it helped me to form an equation, and algebraically I solved it, and I get velocity of Q is 0.56. So now we know the velocity of A is 1.5 in that direction, and velocity of Q is 0.56 in this direction, right hand side. So let's find out the distance between them. Do you know what we will do? Can you think? You know the velocity of both, okay? And you know that both of them will travel 3 seconds. So what do you think? Okay. So now this is what we have to find out, right? I gave you thinking time. So now I will find out, I'm just giving you a hint. If you want to pause a video and want to try it out yourself, you can. So I will find out how much distance covered in 3 seconds by this object and by this object. It is in this direction, right? So distance covered by P is speed into time. So minus 0.1 into 3. So minus 0.3. So whatever the point is after the collision, so don't think I'm not considering this distance. Actually what I'm saying is right after the collision, when they were here, it started moving in this direction and it started moving in this direction, okay? So the distance covered by body P is minus 0.3. And distance covered by Q is speed into time. We have just calculated velocity of body Q is 0.56 multiplied by 3 is 1.7. So from the point of collision, this has traveled minus 0.3 and this has traveled 1.7. So altogether the distance between them is 2 meters. So this is what we had to calculate. So you can say after 3 seconds, the distance between P and Q will be 2 meters. So let's see another example. Okay, so this is second example of this video. So this is about 3 particles or 3 body, okay, P, Q, R. You can see from here that P and Q are traveling towards each other. R is also traveling in this direction, but the speed is very slow. So initial part of the question is giving you their masses. I will show you in the diagram. The mass of P is 0.4, mass of Q is 0.3, and mass of R is not given. The velocity of P is u meter per second, Q is 8 meter per second, and R is 3 meter per second. So this is the question given in the description. Now question is saying that after the collision between P and Q, their direction of motions have been reversed, but their speeds are unchanged. And we have to calculate u, which is the velocity of P. So we will read part 2 of the question later. So let's find out the velocity of u. So this is the diagram of the description explained to you in the question, that P and Q are moving in the opposite direction, right? It was given in the diagram also, and these are the velocities and mass of them. So first of all, we have to consider the collision between P and Q. So I am finding out here before collision what is the momentum of body P and Q, right? So simple mass into velocity. I have just written by mistake u, you can write here v, okay? I mean to say that u was given to me in the question, so instead of v, that's why I'm using u. So before collision, the momentum of P and Q is what? 0.4 u minus 2.4. Now I'm taking this minus because the direction of Q is towards left, so I can write here minus it. So to avoid any confusion, okay, -8. Anyway, so this is the momentum before collision, okay. So now we will see after collision what is the momentum. So momentum is mass into velocity. So I'm finding out of P after the collision, which is minus 0.4 into U. So the only difference is because question says the velocity remain same in magnitude, but direction reverses. So that's why I'm using minus sign. Earlier P was going like this, now it is going like this towards left. And Q is now 8 instead of -8. Earlier Q was going like this, but now it is going like this, okay. So this is the momentum of body P and Q after the collision. So using law of conservation of momentum, I'm just putting these two momentum equal to each other. You can begin with equality sign and write it, or you can write separately and then equate it. It's up to you. So then I'm using algebra, simple algebra, and I found that velocity of U is 6 meter per second. Now part B was saying that now Q, because we have seen from here that Q is going in this direction and R was coming from there, so it means they will collide. So question is saying that after the collision, so rather let me show you the question. The question was saying the next collision is in between Q and R, right? After the collision, Q has started moving in this direction. So after the collision between Q and R, particle Q is at rest and R has speed 9 meter per second. So we have to find out the mass of it. So let's see. So if we see here before collision between Q and R, this is the direction of Q, this is the velocity and mass, and for R, this is the velocity and mass. So let me write here -3 to avoid any confusion, okay, -3. So this is the velocity and mass of R. So momentum before collision between Q and R is this, right? So what I have done, mass into velocity of Q, mass into velocity of R. You can see from here I'm plugging in these values, right? So I got this mass before collision between Q and R. Now it was given in the question that after collision Q comes at rest and R moves with velocity 9 meter per second. So we have to calculate M. So let's find out the momentum of the system after collision. So for Q, mass into velocity. You can see from here I'm picking up mass and velocity plus mass into velocity of R. So this is Q, this is R. Simple plug-in. So I get the momentum of the system 9m. Okay, this is the momentum of Q and R after collision. So by using law of conservation of momentum, I'm putting the momentum before collision equals to momentum after collision. So it helps me to form an equation and I calculate the mass of body R, which is 0.2 kg. So with this I will end my video. Thank you very much for watching the video. If you have learned something from it, do press like and subscribe. You will get the indication of my new videos, and your comments really encourages me. So I always wait for positive, constructive comments. And in next video I am coming with geometrical distribution. So thank you very much for watching this video. Bye bye. Take care.